Okay, let us start our discussion on concavity and convexity in polar curve. We already know that the polar curve is represented by r is equal to f of theta. Means the r is a function of it means any point on a curve is represented by some r and theta here, not x coordinate and y coordinate here. It means that it is indicates how much distance from the pole and how much the r radius vector makes with an angle theta. If you make an angle theta and if particular this theta, this is the, because r is a function of theta, as for a particular theta we have r, then only you can get these points, all those points. In that case, that if suppose polar concave curve is there, how the, what is the condition we can get it, and um, if convex curve is there, what is the case? Okay, once we know about the polar curve, let us, the curve is concave, this is the curve, and pole is like this. Okay, pole is like this. Whenever, suppose you take, you choose initially point p0, we are going to choose point p0. These are the known things. Okay. Whatever the theta, it makes an angle with the x-axis, that is theta, and the angle between the radius vector and tangent is, I can say that that is 5. And whatever the, we can draw tangent at this particular sorry, you can draw perpendicular, this is p, with an tangent that is got perpendicular length. See what happens as r increases here, r changes, not increases, the perpendicular length also changes here. But in case of concave curve, what happens actually? Concave curve, whenever the curve is there and pole is concave, curve means the curve is concave to the pole here. In this case, what is the condition? We have to derive it. The curve is concave to the pole whenever we initially we choose, let us choose the point p0 where p is equal to r, means if you draw perpendicular at that length, and whatever the angle between the radius vector and tangent, let us assume that they are equal. We are going to choose such a point for our understanding this, how in concave curve dp by dr, the ratio of derivative of dp by dr is greater than 0. Just we are going to choose a point where the perpendicular length, the tangent is perpendicular to the radius vector. In that case, whenever they initially choose the point p0, as we move the point, what happens in this case of concave curve, what happens, the both changes the perpendicular, see the tangent comes here, the r is here, and the whatever this the perpendicular length from the um, perpendicular length from the tangent to the radius vector, from the tangent to the pole, is also increases here. See, if you draw tangent here, if you point it, that the perpendicular length maybe here comes like this, means what we can get it, you may, the r will going to decrease or increase, the both will change in the same direction. In case of concave curve, suppose if you coming here, the r may be decrease, definitely the perpendicular length also will going to decrease here. If you coming here, the r will going to decrease, means um, I can say that perpendicular length also decreases here. Both are moving in the same direction, means I can say that the change in the, whenever they move in the same direction, the ratio is same here. The r, that is dp, means change in the perpendicular length to it by change in the perpendicular, I can say that change in the radius vector, we can say that they move in the same direction. Okay, maybe at the, where the perpendicular move here, the point is p here, if you move the point p here, The you are looking that the radius vector length is going to decrease here. The similarly, what happens in that case, the perpendicular length also is going to decrease. But as we move from the point here, what happens, the length and p are going to increase in the same way. That's why it's the case. Therefore dp by dr is greater than 0 in case of concave to the pole. When coming to the convex to the pole, the the pole is out, the whatever the curve is convex to the pole, here the pole is somewhere here, that curve, and from that pole if you choose a point p0 initially, where I can say that uh, as we move from that, as we move, the point p moves here, whatever the perpendicular length, what happens, suppose r decreases here, see here, r decreases, the perpendicular length will going to increase here. As we move, see here, if you suppose somewhere, if you choose the point here p here, you draw tangent at this like this, and this is the we can say that the perpendicular length and p are same. At that case, both radius vector and perpendicular length, the tangents are perpendicular, let us assume that. And if you move the point here, if you choose the point, what happens, the radius vector will going to increase here, but the tangent is coming the perpendicular, whatever the uh, tangent, the perpendicular length will going to decrease here. See, because as we move, the tangent is inverting towards the pole here. That's why the r increases, p decreases here. They both, if dr is positive and dp is negative, therefore I can say that dp by dr is negative here, the convex to the pole. See, with the diagram you can clarify here. Whenever, suppose if you draw tangent here, if you choose a point initially here, what happens, this is the radius vector, and whatever the perpendicular may be somewhere here only. As we move here, r increases, what happens, suppose if you point move here, the if you draw tangent here, then what happens, somewhere the perpendicular length, the r increases, the perpendicular length will going to decrease here, because the tangent moving inward here. But here, as r increases, what happens in this case, the the p will going to increases here. As r increases, p also increases here. But in case of the convex, the r increases, p is going to decreases. Therefore we are going to get a different ratio, that is dp by dr is less than um, this 0. Therefore we can say that dp by dr, where inflection point means, we come to conclusion that whenever the curve is concave, whatever the ratio concave to the pole, very important, whenever the polar curve is concave to the pole, whatever the dp by dr is, I can say that is greater than 0. But whenever the pole is convex to the pole, the curve is convex to the pole, the dp by dr is less than 0, less than 0. It means that whenever the curve changes from concave to the convex, what happens, the concave to the convex, the dp by dr will going to change it. It is positive to negative. While moving the dp by dr from positive to negative, somewhere it is going to become equal. At that point where it is called inflection point, that is called inflection point, where dp by dr is equal to 0. That's all we are telling that the starting point we are going to choose here and all those things. But if they given example, they ask to find out the based on these formula, we going to, if suppose r is equal to f of theta, they given, we have to find out dp by dr first, and then you tell about the curve is convex or concave, like that we can tell. This is how we can understand. But one more thing is, we know that, what we know, the the rho is what? The radius of curvature is nothing but the um, one in this radius of curvature is equal to dp by dr is equal to r by p, r by radius of curvature. Okay, then you can get 1 upon the you get 1 upon rho is equal to or you can say that rho is equal to r into dr by dp here. Okay, what are based on this formula, if suppose dp by dr is negative, the radius of curvature will going to get negative. Directly you can say that if the radius of curvature is, I can say that if you get positive, what we can get, you can directly say that it is concave curve. If radius of curvature is negative, I can say that directly say that is convex. Based on the radius of curvature only you can tell if the curve is concave or convex to the pole. This is very important, to the pole. I'm telling you. Okay, this is because radius of curvature depending upon this ratio, the sign of the, therefore we can only on the sign of only you can tell like that. Okay, thank you very much.